Today's lesson is on trapezoids and kites, and now keep in mind that up until this time we've been talking about parallelograms a lot. These two polygons are not parallelograms. Okay, so let's start with the trapezoid. What is a trapezoid? It's a quadrilateral with exactly one pair of parallel sides. So here's what a trapezoid looks like. So here would be my parallel sides. Quadrilateral. So the parallel sides are called the bases of the trapezoid. So here's a base, here's a base, and the other two sides are called the legs. So here's a leg and here's a leg. Trapezoid has two pair, oops, no, sorry, I'm getting ahead of myself. A trapezoid has two pairs of base angles. Sorry about that. Each pair shares a base as a side. So here's a base angle, and here's a base angle, and that's a pair, and then there are base angles down here as well. Base angle, base angle. And you see how each of those in the pair shares the same base. The non-parallel sides of a trapezoid are its legs, and I've already labeled those over there. If the trapezoid has congruent legs, then it's an isosceles triangle. Trapezoid. I may make that mistake a few times in this video. I'm so accustomed to talking about triangles. So here would be our isosceles trapezoid. Legs are congruent. The bases will always be parallel in a trapezoid. So there's an isosceles trapezoid for you. Okay, we got a theorem. If the quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So in this picture you see here on the side, angle A would be congruent to angle B, and angle D would be congruent to angle C. So let's see how we might use that here in a couple of examples. Find the measures of the numbered angles in each isosceles trapezoid. Okay, well we know that angle 1 here is congruent to this base angle, so the measure of angle 1 is 49 degrees. We know that angle 2 is congruent to angle 3, but how do we know what those measures are? Well, we got to look at these parallel bases here. And so let's say this is our transversal. If we use this as our transversal, angles 1 and 2 are consecutive interior angles. We know that those are supplementary, so we know that the measure of angle 2 is going to be 180 minus the measure of angle 1, which is 49 degrees. So the measure of angle 2, which is the measure of angle 3, is going to be 131 degrees. Okay, that's number 1. You pause here and do number 2 and come back and check it. All right, I got the measure of angle 1 to be 105 degrees. The measure of angles 2 and 3 to be 75 degrees. If you didn't get those and you can't figure out why, let's talk about it in class. Okay, we got another theorem here. If a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So AC is congruent to BD. So now it says, let's prove this theorem. Okay, let's do that. Gonna have our statements, gonna have our reasons. You know what I want you to actually do here is, I'm going to let you pause and try to do this by yourself. That'll save us a little time in this lesson. So let's see, I'm trying to show that AC, I'm going to mark that, and BD, I'm going to mark those with blue. That's what I'm trying to do, prove this theorem that says those diagonals are congruent. So let's think about this. Probably, I'm going to give you a big hint here. I think what I need to do is I need to show that triangle ADC is congruent the triangle BCD. And how is that going to help me? Because AC and BD will be corresponding parts. So why don't you take that big hint that I gave you there and pause and try to write this proof by yourself. All right, there we go, guys. We start with our given step, of course, and then let's look back up here. Oops. Look back up here at our diagram. I know that this angle here is congruent to this angle here. Why? Because of the theorem I just learned that said the base angles of an isosceles trapezoid are congruent. So once I got that, then I look up here and I say, okay, these two triangles that I'm looking to prove congruent share this side, CD, so I'm going to say it's congruent to itself. And of course, that's the reflexive property. And then I can say the two triangles that I wanted to show are congruent by side angle side. And then finally, I can say that those diagonals of that trapezoid are congruent to each other because they're corresponding parts of congruent triangles. Okay, moving on to the midsegment. The midsegment of a trapezoid connects the midpoints of its legs. That's what a midsegment is. Very much like a midsegment of a triangle. So you can see, here's what it looks like here. MN would be the midsegment in this picture because M is the midpoint of this leg and N is the midpoint of this leg. So we got a theorem here. It says if a quadrilateral is a trapezoid, then 1, the midsegment is parallel to the bases. So let me just draw that in there. And number 2, the length of the midsegment is half the sum of the lengths of the bases. So in equation form, that says the length of the midsegment, MN, is 1/2 the sum of the lengths of the bases. So BC plus AD. Okay, so let's do an example. QR is the midsegment. What is X? So what we just learned in that theorem is that X plus 2, the length of the midsegment, is half the length of the sum of the bases. So 4X minus 10 plus 8. All right, I'm going to multiply both sides by 2, so that's going to give me 2x. Sorry, my pen's not working very well. 2x plus 4 equals 4x, and negative 10 plus 8 would be minus 2. Now I just got to solve for x, so 6 equals 2x, therefore x equals 3. That's my job, but you know what I want to do is come over here and check that to see if that makes all these lengths come out to be what I think they should be. So if x is 3, that makes the midsegment 5. It makes base LM 12 minus 10, 2. So the midsegment is 5. The sum of the bases is 8. So indeed, the midsegment is half the length of the sums. Okay, so that's it for trapezoids. Let's talk about a kite. A kite is a quadrilateral with two pairs of consecutive sides congruent. So look down here. Here's a pair of consecutive sides. They're congruent. And no opposite sides congruent. Why can't opposite sides be congruent in a kite? Well, because then it would be a parallelogram, right? And we know that kites and trapezoids are not parallelograms. So there's my other pair of consecutive sides that are congruent. So we got a theorem that says if a quadrilateral is a kite, then its diagonals are perpendicular. Okay, so we got a little proof here. What are we trying to prove? Given kite ABCD with AB congruent to CB, CD congruent to AD, we want to prove, let me mark these in green, we want to prove that angle BCD, this one right here, is congruent to BAD. All right, I'm going to pause and set up my two columns with statements and reasons, and then we'll come back and talk through this. Okay, I redrew my kite over here so I didn't have to keep scrolling up. All right, we're trying to show that this angle here is congruent to this angle here. So I hope you've already figured out that, I probably need to show that this triangle is congruent to this triangle down here, and then those two angles will be corresponding parts. So, boy, we're almost there already, right? All we need to do is say that BD is congruent to itself, reflexive property, right? And then we've got it. We've got our triangles. We know that triangle BCD is congruent to triangle BAD, BAD, by side, 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 right? Side, side, side congruence. And all we need is our last step that says angle BCD is congruent to angle BAD because they're corresponding parts of congruent triangles and therefore they're congruent. All right, I want to take this minute to point out a few other special things about kites. Not just that those two angles, so these two angles that we just showed are congruent, these right here, those are associated. Let me go back up to the better picture that we have here. So those are the two angles that are associated with the short diagonal, right? So those two angles in a kite, so I'm going to call them the short diagonal angles. They'll always be congruent. This is some good stuff I'm telling you right here, so don't go to sleep right now. The short diagonal angles, so the ones that we just found are congruent, those will always be congruent. Okay, the next thing is the long diagonal will always bisect the short diagonal. So let me do this. Okay, so the long diagonal will always bisect the short diagonal. So those two little parts will always be congruent in a kite. And finally, I'm going to put your other very important statement over here that says the long diagonal will always bisect the two angles. How do I want to say this? Look here, guys. I'm talking about this one, BD. This long diagonal will always bisect, I'm just going to say the two angles it intersects. That might not be the best terminology, but I can't think of a better way off the top of my head to say it. But look what I got. This long diagonal always going to bisect that angle and that angle. It's also going to bisect the short diagonal. So think of it that way. The long diagonal bisects two things. It bisects the short diagonal and it bisects the two angles of the kite that it comes in contact with. The two angles that are on both ends of the short diagonal will always be congruent. That's what we just proved in that little proof we did. Okay, so the rest of this lesson is just some practice problems for you to do. So of course you're going to pause here and I'm going to show you the answers when you get finished. Okay, here's our first problem. We needed to find the measures of angles S and U, and as I told you up above, those two angles will always be congruent. We proved that. So the only thing besides that I really had to remember is that the sum of the measures of the interior angles of a quadrilateral will always be 360 degrees. So I just write an equation, and I know that since these two are congruent and I solve that, I get 125 for the measure of both of those angles. Okay, in this kite here, they tell me that the short diagonal is 38 units long, ED is 41, so sadly that's not a Pythagorean triple, so the method, but I do know it's a right triangle because the diagonals are perpendicular, so I got to use the Pythagorean theorem, and I end up with 2042, and I don't think there's a perfect square in there, but you can think on that for a minute and let me know if I failed to catch it. Okay, kite FGHI. We're trying to find this angle here that I've marked. We know that this triangle FGJ that I pulled out is a right triangle because the diagonals are congruent. And remember, I told you up above that these two angles are congruent because that long diagonal is always going to bisect that angle. So when I set those two equal, get x equals 4, I find out this angle here is 19 degrees. And of course, I know the two angles that are not the right angle in a right triangle are complementary, which gives me 71 degrees for that angle. Okay, next problem has to do with the mid-segment theorem, trapezoid and mid-segment theorem. So I just use that information, solve for x, and of course once I get my value for x, I want to plug it in like I did here to make sure that the mid-segment is half as long as the sum of these bases, and indeed it is. And finally, on this last kite problem, we just have to use all those great facts that I told you up above. I know angles 1 and 3 are congruent because they're right angles, because the diagonals are perpendicular. And remember how I told you the long diagonal always bisects these two angles. That means the measure of angle 5 is 35 degrees. 2 and 4 are congruent because if you wanted to, what I know is that, let me get another color here. Let me get blue. These two triangles, this triangle and this triangle, are congruent, and I could prove that if I wanted to. Of course, these two triangles over here also would be congruent. The big triangles are congruent, so that's the great thing about the kite. All these sets of triangles are congruent, so that's how I know that the measure of angles 2 and 4 are equal, and that would make them 55 degrees each. All right, that's it for trapezoids and kites. See you next time.